Okay, let's go. Good afternoon, everyone. Nice to meet you. I'm Jeremy Pico-Clement, Technology Manager at Epic, and I'm really pleased to welcome you for this Epic Online Technology meeting on food and beverages. So thanks to our sponsor for the today's event, Photonics and Vortex Optical Coating. So few words about Epic. Epic is the largest photonics industry consortium in the world with more than 800 members. So we act as the catalyst of European photonics industry by offering a wide range of services to our members. So from technology support to access to different markets where photonics is involved, including market reports, networking events, for example, mentorship, HR support as well, and investment advices. Here is the Epic team, 11 people, all passionate by photonics. So I'm personally part of the technical team with my colleague Antonio Castello, who is in charge of laser and medical, and Ivan Nikitsky, who is in charge of PICS and quantum. But as you can see, we have a team for marketing as well and event management. Epic is also part of several European projects, as you can see on this slide. So JPICS, the manufacturing pilot line for indium phosphate PICS. MedFab, a pilot line dedicated to new photonics technologies for medical diagnostics. Multiple, a project related to multimodal monitoring solution for production quality and efficiency. We're also part of Fabulous, which is a European pilot line for the manufacturing of freeform micro optics. Photon Hub, an innovative hub offering comprehensive range of supports to industry, and also Pulsate, an European network for empowering SMEs digital competencies in laser and additive manufacturing. Here is a quick overview on the next events Epic will organize, so on-site, but also online. So as you can see, we'll be at Optro, so it's a defense event in Bordeaux, France, where we'll organize a roundtable. We also organize several events during Photonic West, where we will be, or the team. So here you have a few examples, like a member networking reception, VIPs networking lunches and reception, members lunch. We organize also 2 different runs. So if you are curious, interested to participate, you can check our website and register. 2 other important meetings are the annual general meeting 2024, which will be organized in Juan-les-Pins, France, in April 2024. And also, end of April 2024, we organize an Epic technical meeting on photonics for agri-food industry. So topics which could be interesting for you. So it will be organized at DG Food in Oslo, Norway. So if you are interested to participate to this meeting, you can contact us. Some speaker slots are still available. So if you find something interesting for you and if you want to talk, you can contact us, you can contact me, and we can discuss this together. A few online meetings we'll organize in the next few weeks, few months. So beginning of January, the new product release. After this, we organize an online marketing meeting, the 10th of January 2024, and then 3 online technology meeting, one on quantum materials, one on laser welding, and one on automotive lighting. So on this slide, you can have an overview of all the companies which registered to this event. So as you can see, we cover the whole value chain from software companies to end users and integrators, including component manufacturers, research and development center, etc. So you will have access to this information on the web page of this event, and as well as the presentation of the today's online technology meeting. And I would like also to ask to one of our sponsor at Photonics, Alexander, maybe to take the floor and to give us a presentation of your company. So Alexander, you can present Art Photonics.
Yeah, good afternoon, everyone. Art Photonics is proud to be a sponsor for this epic webinar. So, Art Photonics is a global leader in mid-infrared fiber optics, but we also produce a lot of fiber optical products, cables, and fiber optic probes for the wide spectral range from 300 nanometers to 17 microns. And usually for food and beverages, people use probes for visible and near infrared. And here we produce probes for fluorescence spectroscopy, for reflectance spectroscopy, transmission and transfection probes. But if you want to be more precise and go to the mid-infrared range where fundamental vibrations is located, we also produce a variety of ATR probes. And for example, on the bottom of the screen, you can see that we can measure milk, chocolate, and other samples using all of our different spectroscopic techniques: ATR, mid-infrared ATR, near-infrared reflection, and fluorescence spectroscopy. Yes, and we also produce different types of probes. So it can be just 1+1 shell, or it can be very complicated diffuse reflectance probes with 0%, almost 0% straight line, or that designed for FTIR or diffraction gradient spectrometers or just sensors to meet your budget. And of course, in some cases, using only one technique or only one channel, it may be not enough. And for example, and we made a research and we produced special combi probes that utilize two or more spectroscopic techniques. For example, on the right screen, you can see that we make fiber probe, ATR probe that can also capable for fluorescence, and we tested on, for example, chicken tissue, and we see that only using two methods it's possible to differentiate between different chicken tissues, liver, breast, and fat. And of course, our probes are compatible with different other novel spectroscopic devices, such as SpectraPod from Mantispectra, where you use detectors with 16 detectors with different coatings and only one light source. Or we also made our own fiber probe with different LEDs as a light source and only one detector. So just to be more specific for chosen application. Yeah. So I hope I was in time. So thanks a lot and enjoy the webinar.
Yeah, thank you, Alexander. Thank you very much. And we'll have a presentation from Alexander later on during this OTM. And I would like also to ask to Yen Reilly from Vortex Optical Coatings to give you words about Vortex, the other sponsor of this OTM. So Yen, if you want to say a few words.
Yes, thank you very much, Jeremy. Good afternoon, everyone. Vortex is an SME based in the UK, and our main area of work is we make filters for the food industry, but in general between 1 micron and 6 microns. And what we're specifically good at is helping companies pioneer a measurement technique or prove a concept. We believe in being in these things for the long term, and we've significantly invested in our coating facility to be able to make these filters, and we enjoy working in that area. So as well as this afternoon, we see it as a growing market. So thank you very much.
Thank you, Jan. And a few words about the agenda of today's event. So we'll start with a presentation from Vision Markets with Ronald Mueller, with a view of with some market inputs of food and beverages. Then we'll continue with a presentation by Yen Reilly from Vortex Optical Coating. Cristina Bertoni will give a presentation for Electrolux. We'll continue this OTM with a presentation by Art Photonics with Alexander. Then Maria Cardona from Embutidos Martinez. Francesco Pagliano from Mantispectra, and last but not least, Robert van Tankeren from InPhocal. So thank you very much for being here today and enjoy the webinar. Feel free to ask any question you have after each presentation. We have a buffer time for Q&A. So now I would like to welcome Ronald Mueller from Vision Market for the first presentation. So Ronald, you can start to share, and the floor is yours. Thank you.
Very well. So I hope you can hear me. I'm sharing the screen. Good. There we go. Yeah, welcome everyone. I think we have a pretty good crowd here together in this market-oriented meeting and webinar. So what I would like to give you is a little bit of an high-level overview on the automation in the food industry, with some insights, so to say, on the end market, right? How is the food industry structured, very roughly, and then also some deeper dives into the suppliers for the equipment that are sold or that are selling to the food producers, and then make their business with all these wonderful photonics technologies of inspection with machine vision or laser marking, laser cutting, measurement technologies, etc. Before we start, maybe some words about myself and my company. The company is called Vision Markets. Our claim is your global growth in machine vision. And we are a company that is exclusively focused on the machine vision market. Okay, so this is our home turf, and machine vision is, let's say, a subset, obviously, of photonics, but a let's say considerable one, I guess. And the findings and the conclusions that we are taking here about specific markets for machine vision are very well, let's say, transferable to the photonics market by itself. So we like to help companies in this space to grow their business, and we do this with 4 different business lines. One is strategy consulting, which also includes market research. That's basically something, or that's the business line where our presentation today is coming from. Then we feed that very well into mergers and acquisitions consulting, marketing consulting, and recruitment. And as you can imagine, with this rather comprehensive portfolio of offerings, we have managed to gather a beautiful set of customers across the world by now. So obviously we are based in Europe, so Europe is our home turf, but just as much we are very well connected to Japan and to North America, and also India, China. The growing markets in the Southeast Asia are also reflected there. And yeah, so that's what we do. Now, as I said, so one of our key reports that we do is about machine vision components, so cameras, lenses, all types of optics, frame grabbers, software, etc. And as part of that report, we obviously also analyze different industries, and food and beverage is one of the key industries here that we are focusing on. And so I'm happy to give you a little bit of a insight into that industry today. On a very high level, as I said, so you might know, or you do know, that there are hundreds of brands available in vision, but what you might, or not all of you might not know, is that these brands are basically allocated to more or less 10 companies that are ruling basically this whole space of the food industry. So it's a very condensed, very, very clustered industry by now. Obviously, lots of acquisitions been going on there in the past. And surprisingly, maybe the food industry as such occupies, or let's say constitutes, like 1/3 of the global workforce. Okay, so they're employing one third of the global workforce, including agriculture, obviously. But that's, I think, quite a huge impact, obviously, that this industry has. It has a lot of impact on the environment, on our living conditions, and let's say on an economic from an economic point of view, it's also interesting to realize that food is something that's quite volatile in pricing. So we had, for example, a 27% increase of prices in food in the US in the last 5 years, which is like a more than 5% per year of price increase. But not all of this is not all of the food that's created is actually going into human or like feeding humans. But 40 of the corn, for example, in the US is used for making fuel. And again, in terms of productivity, 75% of the global deforestation is due to agriculture. And by 2050, we have such a growth in the world population that we need 50% more food by 2050 than we used to need in 2010. So all of that is frightening on the one hand, but also I think promising on the business from the business perspective, because that indicates that there is a continued growth ahead in this industry, a continued need for higher productivity, higher yield. We will get to that later on. And that's so to say, in the long term, mid and long term, a very positive outlook as a target industry. So some numbers here. We again analyzed, so to say, the target markets, meaning the food and beverage producers. What we did here, we basically aggregated the revenues of 8 major companies. I mean, you can imagine who they are, right? It's Nestle, it's Coca-Cola, PepsiCo, and so on. And we're tracking, so to say, over time, over several years, we are tracking how the revenues and the profitability is evolving in these different companies and in this different market as aggregation of those companies. And just in 2023, you see a 10% growth, not inflation adjusted. We have to bear in mind in 2023, in light of, let's say, industries or economies where we rather saw recession in the case of Germany, or let's say a very, very slow growth, a 10% increase is quite solid. And also you can see that the profitability, which obviously also speaks for the ability and the interest of companies to invest into technologies and enhancing technologies. This profitability depends quite a lot on the company. So again, PepsiCo, Coca-Cola are extremely profitable, while others are not so much. And that's obviously depending a little bit on how the product portfolio is determined and how the branding is done. Yeah, all right. So how are these companies now getting their solutions in automation? And this is a scheme, so to say, a schematic of the supply chain in machine vision, but it holds true, I think, for many other technologies. Because of the complexity of these technologies, this is a very scattered supply chain, as you can see. From the component OEMs, they are delivering something to vision system integrators or photonic system integrators. They are delivering some subsystems to machine builders. The machine builders feed that into production lines, and then at the end of the day, someone like Krones or someone like Nestle or Coca-Cola is actually using it. So that's again a schematic schematic view on that. As some of you might know, obviously today Coca-Cola has their own machine vision experts in-house. They have their own teams. They are buying directly, and they're selecting directly the components that are going into their factories. But that's an evolution over time. When a company started with that type of technology, they were not very knowledgeable about it, so they had to go through all this supply chain. Today, they're much more focusing on building knowledge themselves and making the best use out of that innovation power behind it. Oh, so when we want to know a little bit more about the market trend and in these customers of us, and us, I mean, I guess we are all kind of, or you are all kind of component manufacturers or subsystem manufacturers. So let's take a look on how these equipment manufacturers for food manufacturing are doing. And As with the food producers, we basically applied a similar concept here for the food manufacturing equipment OEMs. So we aggregated 13 major companies. One of them, this let's say brown company at the bottom, is the company Deere, or you might know them as John Deere, a huge company which lots of activities, not just in agriculture, but also in construction and so on. So we still wanted to take them in here because their footprint in agriculture is massive. And that's actually also one of their major investment areas. So we wanted to take them in here, but on the other hand, we're also kind of Xing them out and bracketing them out in the analysis, as you can see. So all these companies together have accumulated revenue of $131 billion in the last few 4 quarters. Deere was doing pretty well. They had an increase of 14% in their fiscal year 2023, but they're projecting a 10% decline in the 2024. Reason for that is more or less obvious. It's the high interest rates are pushing back and preventing major investments. The financing costs are just too high, as the Fed and the ECB, etc., wanted it to happen. So that's why we are seeing a decline, or they are forecasting a decline in their revenues here. A big company also, AGCO or AGCO, is a huge company again with lots of brands like Fendt tractors, you might know, and they're doing seeds and what have you. They did really well in with 21% in the first 3 quarters 2023, which is impressive. And in South America, they actually grew by 26%, which is even more, let's say, remarkable. But not so. Their growth, for example, in the machines space, does not come so much from tractors like the traditional tractors, but more from combines. So the complex machines which have more automation on board and are able to process the food actually during harvesting. Another example, just for the sake of let's say to be concise here, the company Krones, which is the market leader in bottle filling machines, they are expecting a growth in 2023 by 11 to 13%, and that's sort of say one of those highlights. So as you can see, obviously, as so often, there are some companies which are doing pretty well, others are not that successful, but all in all, we can expect a growth in this industry by 5% for 2023. And also for 2024, it's somewhere between 4 to 6%, according to our estimates by now. And that translates to a even larger revenue growth in everything that's high-end technology equipment, because the new generations, the new machines are using much more cameras, lasers, and what have you than the traditional ones. So in light of recessions and downswings and lots of struggles, as you might have seen in the recent news about the machinery industry and even our industry, this is an industry, a target industry for us, which is attractive to be in for the next year. Good. What are the driving factors? Really jumping over this very quickly in light of the time. Most of them might be aware. You might be aware of. Our society and our gene pool is deteriorating. So we have lots of allergies and diseases of modern society, which are increasing regulatory requirements to make sure that the ingredients of the food is regulated and controlled. We need tracing, and we also want to avoid human errors, right? So that's a clear motivation on why you want to automate in the food industry. The increase of quality, I think, speaks for itself from an aesthetic point of view, as well as the preservation of nutrients. The yield must be increased to reduce waste, so to inspect ingredients at the very early stage in the process, so that they are not even getting into the process and not, so to say, polluting, so to say, the other ingredients that are also costly. And we need precise packaging. Productivity must be increased, but at all costs, right? We have pressure from a growing population. We have cost pressure. The throughput must be increased. And that feeds actually in the next point also, which is the labor issue. So I have been talked to system integrators in the US, which said, like, if I just had, or if our customers had 3 times more workers, they could sell 3 times more stuff, food, okay? So as a matter of fact, they are automating at all costs, because the more they can produce, the less they are dependent on human labor, the more the more successful their business is. And the other driver obviously is innovation. We will come back later. Your AI, deep learning, 3D vision, hyperspectral imaging, laser processing. I think we have a presentation on that later on. That's basically just for inspiration. There is a lively startup landscape in food. We have new processing methods with lasers, with robotics. Intelligent Robotics, you might know, is a small company in the US which came across with a system that uses 3D cameras and robots with saws at the gripper of the robot. And they are cutting meat, fully automated, based on 3D technology. We have smart home appliances. There are cutting boards with integrated cameras that recognize if you have a pepper or whatever, a cucumber or something, recognizes the nutrition values, like the proteins, the calories, etc. They weigh it, and by that, so to say, the very food the food-oriented person then can recognize how much of the different nutrients he is taking. Yeah, so far about that. Just as a remark here, we are doing this flagship report about the machine vision market, its components by component type, by region, by industry, as well as lots of other reports that we do and we did recently. So you're cordially invited, obviously, to reach out to us if you want to learn about specific industries, specific regions, specific markets. We are happy to share our knowledge and help you to thrive with your business and make you invest into the right steps and the right strategies for the growth in the next years.
Thank you. Sorry, let you finish one.
Thank you.
Thank you very much, Ronald, for your presentation and interesting inputs. So I have already one question in the chat. So how many units do you estimate the volume for machine vision cameras in 2023?
Well, this is a good question. This is a tricky question as such. I would say, this is actually a core part of our report, so I honestly don't want to I'll say too much about it, but we have a decline compared to 2022. I think this much is clear. We are struggling in the market a lot in the US and partially even more in Europe, partially not. So it depends a bit on the industry. Logistics is horrible in the US. As you saw, food is good. And let's say the classical high-end machine vision is also positive. Semiconductor is picking up. So that's, so to say, the view on that. In the future, we will see a decrease in the average cost per camera, which obviously means that even when the revenues are growing, the number of cameras are even growing more. And that's, I think, something what I want to and can say about that at this moment.
Thank you, Ronald. Another question from Lars Benesch from PCSP. Lars, do you want to ask your question yourself, please?
Yes, very interesting report indeed. Which technologies do you expect will be adopted within the next year, looking into machine learning, AI, multispectral?
So let's say the adoption of AI is a topic by itself, right? We have done a dedicated study just about that. What is preventing basically customers to adopt it further and faster? actually as fast as we expected it to, or many expected it in the first place. So again, deep learning and AI is basically going through the same evolution as machine vision did 20 years ago. Okay, so 20 years ago, machine vision was a kind of voodoo magic, and some believed in it, some didn't. Those who did tested it, tried it, and some of them were happy, some are not. We're going through the same thing now with deep learning. The issue with deep learning, though, is that we are engineers, or many are engineers, and we don't understand exactly why the system is doing what it is doing. And this is something which is hard to stand for engineers. And that's why deep learning has an even harder stand in that case than machine vision did in the previous phase. But I think by now we have so many beautiful, successful stories where deep learning has been proven to really create massive value and solve problems that were not solvable, or at least not profitable to solve before. And I think that's certainly a big thing. And the other thing is multispectral imaging. I wouldn't go as far as hyperspectral, but multispectral imaging, where you don't need the whole 464 bands of all different spectrums. It's in most applications, it's enough to have 2, 3, or 4. So you're choosing illuminations and optical filters to just use these 3, 4 bandwidths that you need to recognize diseases in blueberries or bruises on apples or what have you. And that's, I think, is already picking up a lot, and that will certainly accelerate in 2024.
Thanks. All clear.
Thank you for your question. Thanks a lot, Lars. And yeah, thank you a lot, Ronald, for your presentation and inputs, market inputs. Thank you very much. So now let's move to our next speaker. So Reilly, Engineering Director at Vortex Optical Coating. So Jan, the floor is yours. You can share your screen and start your presentation.
Okay, hopefully it's just about to come up.
Yes.
Try again. Oh, that's better.
It's good.
Okay. Good afternoon, everyone, and thanks very much, Jeremy, for the introduction. A few facts about Vortex. I don't want to labour it too much, but we're based in the middle of the UK. We have been around for a few years now. We are independently owned, and for the manufacture of our optical filters, we use magnetron sputtering, which is regarded as state-of-the-art technology for infrared applications. Anyway, one thing we do notice, though, and it goes back to what Ronald was just saying there is a higher demand for a higher quality filter within the marketplace, and it particularly rolls into all these new applications and challenges and problems that are out there. And we've been an EPIC member for 7 years now. We like this sort of format on the webinar as well. So going into the food industry and the type of things that we get involved with, infrared spectroscopy, which is what we're really talking about here, has been used in the food industry for probably 30, 40 years. And one of the areas that it has traditionally been used in is the detection of fat levels in food, proteins, and moisture as well. But more recently, maybe in the last 10 years, it's been used for things like looking for contaminated or adulterated foods. So examples of that, particularly in the third world, milk contamination is a problem. And then probably a little bit closer to home for all of us, things like olive oil purity is an area of interest as well. We also get involved in applications to do with the ripeness of crops. So that applies equally in the field as it does to in the supermarket as well. And again, we've just heard there that there is a substantial amount of food that is wasted. And the feeling is that if supermarkets could control their stock rotation a lot better, then that level of waste could be reduced quite significantly. Farming, again, another important area. So looking for diseases on crops and trying to detect pests as well that are going to damage crops, and issues to do with farming efficiency as well, such as reducing fertilizer use. And do you know what? There's applications that are coming to the table every single month. So there'll be something next month that we, is a new challenge for us. And the IR really is the area where a lot of these differences are known about or can be measured, certainly. And we're looking at the materials in terms of differences in their reflection or their transmission. So just to explain what the filter actually does, the filter is the bit that really highlights the fingerprint for the certain material that we're looking to study. And the way that works is these materials have all got modes of vibration which correspond to certain wavelengths of absorption within their spectra. And the other point that's worth noting is that these signals they're very, very big, much bigger than the corresponding vibrations that occur in the visible. So we're looking for a big target, and we all know that when we're looking for a big target, it's a lot easier to find and define. So a little bit of more the traditional thing. This is the type of thing we're talking about historically in the food industry, where light is typically shone on a production line, usually a conveyor belt of food being processed, and then we're looking at the light that's coming off that product, usually through a filter wheel. So in this filter wheel, there'll be a wide range of filters looking for different moisture, different proteins, perhaps, all manner of things. And then, of course, there's the software and the electronics, which makes it into a readable format so that the production line can be run and quality can be controlled. So this is the type of thing that we're talking about. You can see in the picture on the right that these potato chips are being monitored for it will be things like fat content and moisture, and there's these heads that are situated all over the line within the factory. So a few specific examples here then. Moisture detection, 1940 is the go-to wavelength for monitoring moisture, and it illustrates the idea here. You can see that the filter itself is very narrow, and then there's a wide range where we say the filter blocks. And that's important because we just want to measure the influence of the water. Picture on the right is a close-up view of it. And these pictures here, which I've stolen, they kind of show the difference between taking a picture with a visible camera and an IR camera. And you can see on the right-hand side that there is still moisture within that biscuit. And within the factory, I guess they would just use that in a PID control loop just to bump up the temperature in the oven to bake the biscuit properly. So that's one application. So for measuring fat, 1750 is a common wavelength used for that. Similar kind of filter. Another example in whey production. Whey is a protein, so it's a byproduct in cheese manufacture, and a lot of these sort of proteins tend to end up in sports drinks and things like that, and that needs to be monitored as well. And 2100 nanometers is the one of the go-to wavelengths for that as well. So there's some simpler examples, and there's some examples that are a little bit more complex than that, and I hope to go into that with the an illustration about lactose, because you can go out to a restaurant now and then you know, the person who's serving you may ask if you have any allergies, and some people may be lactose intolerant. So we need to be able to monitor that within the food manufacturer as well. So this is the infrared spectrum for lactose, and it highlights some important considerations here. There may be other materials within that mixture, such as sucrose, for instance, that have got very similar spectra, okay? And then quite often as well, there'll be water within the mixture. So it's not as simple sometimes as it first appears. So we want to avoid areas where water is strong, but we also want to avoid other materials that are in there. We don't want to achieve a false positive result. So when you consider the spectra of all those three materials, if you were able to make a filter that concentrates on some of the differences, i.e. the one I've ringed there, you could make a filter like that, and that would enable you to monitor the level of lactose within this mixture. Excuse me. So that's one example, but sometimes there may be 2 or 3 filters that are needed to do this, and that's why a lot of these applications tend to involve these filter wheels, which are continually rotating, looking for a wide range of materials. So that's a brief overview there, and I wanted to finish off with the epic questions, which I'm sure a lot of you know about. And the first one is always, what can we do for you? Well, we can make your detection dreams a reality. And what we're particularly interested in is we're particularly interested in the newer sort of challenges and applications out there as well. And we're quite happy to work with people on that. It's only through collaboration and discussion that we can make some of these problems solvable. And the other thing, of course, is what can a community do for us? And one of the things that is quite obvious to us, having been involved in the area for a number of years, is that the price of detectors is just too high. When you compare, say, indium gallium arsenide and lead sulfide detectors, which are the 2 most common detectors in this part of the spectrum, they are very expensive compared to silicon detectors for the visible. So if somebody out there has got a low cost detector, that really would be a game changer. And of course, at some point, we want to be able to put these things into a phone as well. So that's really a brief overview of how infrared filters and infrared spectroscopy can play a role in this area. And that's my contact details, and I'm happy to take any questions at all.
Thank you, Jan. Thank you very much for your presentation. Any question for Jan, you can raise your hand. We have a question from YouTube. Is that possible to make the filter directly on the SWIR detector? Jan?
It is possible, okay, but there is a little bit of a risk there, in that whenever a filter is manufactured, there's normally a sequence of test runs done before the glass or silicon is put into the machine. So there is a risk there. And obviously there's a lot of work gone in and a lot of expense gone into making the detector itself. So the preferred way of manufacture at the moment is to manufacture them separately and then bring the 2 together.
Thanks. Yeah.
So possible, but there could be repercussions there if it goes wrong.
And yeah, I have a question regarding hyperspectral cameras. Do you already provide some filters for this industry? How do you see these technologies? And
Yeah, actually, I echo one of the points that Ronald was making at the end of his presentation. In the food industry, when you compare it with things like oil and gas and semiconductor, the level of investment over the years hasn't been huge when it's compared to other industries. And what these guys are often looking for is a low cost solution to a problem, and hyperspectral can be quite expensive, whereas as the Ronald was saying, you perhaps maybe only need 4 or 5 wavelengths, and I know it's old school, but using that filter wheel means that you can do that quite easily and avoid reinventing the wheel in a lot of places, but with hyperspectral imaging you get a huge lot of information, and quite often it's an overload. It's too much, and one of the problems with hyperspectral imaging is condensing the massive information down to the bit that you really need, or the bit that you really want to look at.
Okay, so you share the same point of view as well. Thank you. And thank you very much. Thank you very much for your presentation again. And yeah, let's welcome our next speaker. So Cristina Bertoni from Electrolux. So Cristina, you can share your screen and start your presentation if you're ready.
Yes. Arriving. Yes.
Good.
Okay. So good afternoon, everyone. Thank you to Epic for inviting me to this event. Because actually I've been working on some projects related to food freshness monitoring inside the refrigerators, and as you may imagine, it's quite a challenging task. So I work for Electrolux, that is a large home appliance company founded in early 1900. Last century. We celebrated 1 century a couple of years back. Started off with vacuum cleaners production up in Sweden, and then with other appliances like the refrigerator and the Electrolux Assistant, a food home cook system for users. And then grew up in the 60s up to the 90s with the acquisition of major brands like Zanussi in Italy. Actually, I'm working in a site of Zanussi, that is now Electrolux, in the northeast of Italy, next to Venice. Also other brands in North America like Frigidaire and Westinghouse, and last but not least, in the 90s, Aige, which is a major brand also today. Okay, this is other acquisitions, but I will skip this. The major brands today for Electrolux are Electrolux itself, Aige, and Frigidaire. We have products in all the product lines regarding kitchen, food, taste, so cooking, preservation. We have also a professional brand working for restaurants and food chains and so on. And then there is the care product line regarding washing machines and dryers mainly, and the well-being, which encompasses all the small appliances like vacuum cleaners or water jar, whatever. In my experience, I've been working in innovation for across products, because I work for a central R&D department that is, let's say, scouting for new technologies to be proposed to our internal stakeholders, that are the R&D units connected to each specific product line. Electrolux is selling worldwide, and we have our major markets, however, are in North America, Europe, and Latin America. Regarding product category, instead, we are covering largely the taste domain, the care, as well as the second and third, the well-being. with small appliances. Okay, there is an acceleration towards sustainability, and we have up to 63% of our consumers that is considering sustainability as an important factor when buying an appliance. And there is, generally speaking, a sensitivity to sustainability that has changed very much and is reaching quite high figures. Electrolux is, renowned worldwide for its efforts in creating products that are more and more sustainable. And you have here a series of awards that the company received in the recent years. We have specific targets of that are science-based, by the way, on CO2 carbon emissions, with a strong reduction in carbon emissions in operations by 80% by 2025 and 25% in terms of carbon emissions by products in use. We are targeting to become climate neutral in operations by 2030 and across the whole value chain by 2050. Now, life has changed after the pandemic, and we have general trends that makes lifestyles very different from before. For instance, here I report a picture from ANAS, that is a national mobility society subject that is managing roads, and they have a sensors network all around the nation monitoring the traffic. And as you can see, we have, let's say, a very strong reduction in mobility in 2020, which, by the way, kept below normality. And in 2022, it was recorded at -11% of mobility, because in Italy we had like 3.5 million people working smart from home. This makes, of course, people spending more time at home and finding perhaps or helping this time spent at home can help people to make them more sustainable. Because sustainability requires time, but we can also provide appliances that makes users more comfortable and in making sustainable actions in all what they do, from preservation of food to cooking to washing. Of course, there are also other indexes related to the home environment that can help people being more sustainable, like to make them appreciating how much energy they use, how much this means in terms of gas emissions, how much they can reduce these gas emissions with their behavior. Also, the thermal comfort is important, because you need to have humidity rates inside the house that enable the thermal system to operate at best, and so on. Regarding food, because now today the topic is food. Okay, consumers, generally speaking, waste food, unfortunately, also because they don't know how to prevent or to avoid this. However, most wasted products are liquid dairy products and vegetable and fruits as well, is around 20%, which is quite a lot. Therefore, it is an important subject for Electrolux to help the users to prevent the spoilage of this type of food items. One of course, possibility is to add a camera and let's say, let the consumer to check what is in the refrigerator and to buy at the shop what is really needed, reducing food waste. But then there are also other strategies related to, here I missed one slide, sorry about that. Okay, it's an introduction slide where I speak about the refrigeration. There are gases that are emitted by fruits and vegetables inside the refrigerator. Among these gases, the one that is causing ripening is ethylene. Ethylene is both emitted by fruits and vegetables and absorbed to be re-emitted. So it is an autocatalytic process. The gas also, this gas in particular, reaches very low concentrations. We are speaking about few ppms of ethylene concentration in food storage containers. In particular, here I show the data collected along several days of storage for these, let's say, items that you see there: apples, broccoli, and lettuce. And we reached over several days, basically, an increasing concentration of ethylene inside the drawer. Though the sealing of the drawer is not perfect. As a matter of fact, the gas tends to reach an equilibrium of concentration, equilibrium between the emissions and the leakages of the gas through the sealings. Now, as I told you, we work with by scouting technologies. Therefore, if we need to be selective, necessarily we need to look into technologies like electrochemical sensing or infrared sensing. Electrochemical is quite established as a technology. We know it, we experimented with it, but for the application in the refrigerator is quite not adequate, because humidity is affecting the sensor quite a lot, reducing even further the lifespan that is expected to be 2 years, but in highly humid environment is going to be less than that. And we need to guarantee 10 years of lifetime, working lifetime. On the other side, there is the optical approach with the infrared band that is certainly offering good selectivity, but in standard, let's say, configurations can be affected by other gases, so there could be crosstalk due to other gases. It certainly offers a faster response time and a longer lifespan. The sensor that you see in this slide is a sensor on the market used in large food warehouses, and is not applicable to our applications. However, even if, of course, it is a challenging choice to go to infrared sensing, we entered into a consortium in 2019 called MIRFAB, where we worked on the mid-infrared sensing of specific target gas mixtures. In particular, we targeted ethylene, CO2, and water vapor inside our drawers. The prototype that we characterized at our labs in operational conditions of interest showed satisfactory sensitivity to ethylene below 1 ppm, excellent selectivity, and reliability in application. However, the prototype that we received is of the size that you see in the picture, and therefore, at the moment, we are actively monitoring developments towards miniaturization, large mass production of these sensors, because they can certainly offer clear advantages and benefits to the food waste prevention and food freshness monitoring. Okay, so this is my presentation for today. I hope I've been clear. Sorry if I missed one explanatory slide. I hope it was clear anyway.
Yeah, thank you, Cristina. Thank you very much. It was clear. Thank you very much. Any question for Cristina? So you can raise your hand through Zoom. Yeah, I have a question for myself, Cristina. I was wondering how you you are used to work with photonics, and how do you see photonics technologies for your challenge? So you mentioned that you work with companies like in a consortium, Mirfab, but do you have any other project? How do you see photonics technology, and how do you work with companies in the field of
Okay. At the moment, as I mentioned, we targeted three gases. That is ethylene, CO2, and humidity. And we see that there are more chances to start working on CO2 sensing. There are already devices available on the market, and therefore already being able to adopt these. Of course, we are not the first thinking to this, and there is an intellectual property jungle that we need to bypass in order to be able to add this functionality. There is still a cost barrier because these devices are available, but still, unfortunately for our applications, they are above the target cost. Therefore, we need, let's say, to proceed step by step. Other possibilities for optical sensing, we see there's quite a lot of interest in the possibility to monitor water or other materials properties with mid-infrared. So let's say gas, water, and materials like fabrics or other items that we may be interested into.
Okay. Okay, thank you, Cristina. Yeah, we have two questions. The first one from Jan, Vortex Optical Coatings.
Hi, thanks very much for a interesting presentation there. You got onto a little bit there, Jeremy. Actually, my question was, I'm guessing that the cost of this it's got to be very, very low, hasn't it? Because of the volume involved. So
yes,
we're talking what, less than €1 for the module that goes into the, say it's a fridge, for instance.
Yes. Well, less than €1, maybe not, but few euros.
Yeah. Okay.
So it's yes, we are waiting at the doorstep.
Yeah. Well, this is what I was saying before. The detector is the major cost. The filter can be diced up into a 1 millimeter square. So that's fairly cheap. But the detector can be, €1,000. It just so that this is where we need low cost detectors, I think.
Exactly. Thank you, Jan. Another question from Mark Juarez from Seus Semiconductor. Mark, do you want to ask? Yes,
sorry. Just that now that Jan spoke about the detector, the prototype that we characterize is photoacoustic detection. So there is a microphone that is quite is cheaper than infrared detectors. That was and the CO2 sensor that I was mentioning is a photoacoustic sensor detection. Yeah.
Okay. Thanks, Cristina. Yes, Mark, do you want to ask your question by yourself? Mark.
Yep. Hello. Very nice to meet you. Thanks for the presentation. So I see that you have a lot of experience with the gas. And is there any way that we can reduce the gas emission from the fruits or from the vegetables by putting some, I don't know, a UV or blue light or green light? Is there any recommendation you have there?
Yes, actually, there is also this part that is related more on treatments, light treatments. Also now is also exploited in green. How they are called in English is hydroponic or indoor cultivation systems
Yeah.
that you have lightning in specific wavelengths with specific timings, reproducing basically the light, let's say, slow down the ripening process. Yes. So you can drive the emissions in this way. But still, the ethylene is an issue because it can really, depending on the sensitivity of the type of fruits and vegetables in the drawer, even 1 ppm of the gas can really impact on the ripening process. Yes.
Okay, thank you. No, interested to learn more about your findings. So let's keep in touch. Yeah. Thank you.
Good enough. Thank you for your question. And yeah, thank you again, Cristina. Thanks a lot for your input and presentation. Thank you very much.
Thanks to you.
And now let's welcome our next speaker. So Alexander Novikov from Photonics. So Alexander, you can share your screen and start your presentation. Thank you.
Yeah, so good afternoon, everyone. Thank you for the opportunity to give a talk. Let's give me a few seconds. Do you see the screen?
Yes, you are not. Okay, we see your presentation mode screen. Okay, good.
Okay, so good afternoon, everyone. I'm Alexander Novikov, R&D manager at Photonics, and today I'm going to talk about promising fiber solutions for molecular analysis in food industry. So a few words about Photonics. It's founded in Berlin, Germany in 1998 by Dr. Vyacheslav Martushenko. We make a lot of R&D and production of specialty optical fiber products for broad spectrum range, from 300 nanometers to 16 microns. We have unique technology and patents for polyxylite mid-infrared fibers, hollow waveguides, and metal-coated silica fibers. And of course, we make a lot of spectroscopy probes for medical diagnostics and industrial process control. And it's a pleasure to mention that a lot of our employees have a PhD degree. So here in the first half of my presentation, I would like to briefly speak about process monitoring, why optical fibers are beneficial in this case. Yeah. So process monitoring and control, why? Of course, first of all, the economical benefit and research. You can maintain product quality, you can optimize processes, enhance efficiency, obtain accurate and reliable data, and of course ensure compliance with regulatory requirements. And you have pretty fast return on investment for PET projects. And how you can do process monitoring and control? Of course, spectroscopy, which is more selective. You use fiber optics, which is more robust. And not to interrupt the processes, you use inline online sampling for real-time monitoring, which saves time and qualified human resources. And yeah, so there are different key spectroscopy methods: Raman, mid-infrared absorption, visible near-infrared absorbance or reflection, and fluorescence, these spectroscopy methods have their own pro and contra. And for food industry, I would say that these last two, near-infrared reflectance or absorbance and fluorescence techniques, are mostly used and of course, for all of these techniques, there are existing fiber probes. And why do you need to use fiber probes? And the fiber optic sensors or probes gives you easy and safe spectroscopy. You don't need you don't have to prepare the samples. You have inline in situ online process monitoring. You have it in vivo measurements, and the fiber probes can be designed in such a way, and there are existing. We produce them that can be sterilizable, yes, using autoclave, for example. With fiber probes, you can do reaction monitoring, you see reaction initiation, endpoint, kinetic determination, and fibers are dielectric, so you can use the fiber probes for hazardous conditions, high temperature, pressure, pH, media, vibrations, electromagnetic waves, and so on. Yeah. So, and moving further, so the ideology we are trying to develop is to, so let's start this way. So we have a lot of European and German projects, and where we noticed that if you use two spectroscopy techniques, for example, mid-infrared plus fluorescence, near-infrared plus fluorescence, or near-infrared plus mid-infrared, so it gives you better results, just better distinguish cancer tissues for in case of humans and animals. It gives you higher sensitivity, it gives you higher accuracy, and our recent published paper where we created this fiber probe for that combines infrared ATR spectroscopy and fluorescence spectroscopy from the same point, at the same time, and we tested it also on. We bought a chicken from the supermarket, different tissues, breast, liver, fat, and here we have shown that if you use only one technique, yes, it's not possible to distinguish between these three tissues. You need a combination. And moving further, here from we measured a lot of spectra, and on this spectra we see that in reality you don't need the whole spectrum. You don't need these big expensive spectrometers. You need only a few selected wavelengths, and here you can use only one wavelength in mid-infrared and one wavelength for in case of fluorescence. That gives you enough information to distinguish between different samples and to better monitor your process. So here just example that family of compact combi probes that we are developing and that they are existing. That first one is ATR plus fluorescence plus Raman. They will be soon we will publish the paper which is under review process about possibility to implement also Raman technique to this probe through ATR crystal. Also, we have this second, third, and fourth probe shown on the slide. They are probes with different channels that gives you possibility to make measurements in mid-infrared ATR, near-infrared transmission, and Raman techniques used for biopharma and R&D research in biotechnologies. Of course, in other areas of application are possible. So this is just a slide that shows kind of ideology about multispectral combi fiber probes. So which technique gives you information about part information of the sample? Yeah, but combining techniques gives you more reliable information about the sample. And don't forget that in some cases you have really challenges to get. In some cases you have very noisy spectra, and in this case these combinations can help you a lot. So yeah, so in our labs we also measured a lot of milk, chocolate, real life samples. So this gives us possibility to measure sample. So here in case of milk, to determine the specific wavelengths where we can put not the big expensive spectrometers, but LEDs and detectors, which is more compact and more affordable. And yeah, here's what I want to talk. What here is what I want to make attention. So speaking about optical multi-sensor systems, when you have analytical device with at least two optical chemical sensors. So, for example, on the right part of the slide, you see the fiber probe, where you have this few LEDs and one photodetector, and it's these LEDs are selected to the specific application, to the specific case. So, and of course, comparing to spectrometer, it has specialized application area, low selectivity. Of course, you don't see the spectrum; you see only the numbers. And of course, in this case, you need an application of chemometrics. But it has relatively low cost. It's compact. It has high measurement speed, autonomous normalization. Of course, you can choose LEDs, whatever you like. I mean, but in accordance with your process. And yeah, so depending on the software, user may not be an analyst to understand from the spectrum what is going on. The software must be written once and gives information for anyone who use the device. Yeah, here on the right bottom part of the slide, you see that, for example, you have two component system, and you need to determine the concentration of which component. And there is also a possibility that some contamination exists in the system. And in this case, it's possible to use, for example, this here is shown that you can use 3 selected wavelengths region where you can put LEDs and detectors, and it gives you satisfactory results for determination of different concentrations. Yeah, and the common opinion that sensor system is not a spectrometer, but at least cheaper, is not correct. So because properly built OMS system can and must be better than spectrometer due to the fact that it's less noise. LEDs can be high power. You can use high power LEDs. You don't collect unnecessary data from different wavelengths, regions where there is no absorption and nothing is happening related to the process. You no need to study wavelengths one by one, so it expands the capabilities of the spectral method. And you can also combine this with other different physical techniques. And here's application case. The source of it is done by our colleagues. You can find the links below. And in this application case, about determination of fat and protein in milk. So where you can use spectrometer, or you can optimize and amount and parameters for different LEDs and use only. Okay, in this case, it was used 7 LEDs, but from statistics, gradation statistics, you will get the better numbers, and you can control your process better comparing to the conventional method with the spectrometer. And here, in this case, it was used visible and near infrared region, but of course, if you go to the mid-infrared region, where fundamental vibrations are located, and you can get, depending on the application, of course, here, so also the ATR probes and affordable sensor, not spectrometer, can be used for example, here for process monitoring in biotechnology, for biomass, glucose, ethanol, etc., etc. Yes, and here's just an example. I wanted to show that you have for near-infrared, you have FTIR spectrometers that broad spectral range, high resolution, but expensive, slow, and sensitive to vibrations. You have diode array diffraction grating spectrometers that have low resolution, low cost, fast, and robust. But according to the ideology I spoke before, so here in our company we created near-infrared moisture sensor where we used different LEDs and a special program that control these LEDs and broad detector. So and this sensor was used for moisture analysis of powders, but of course can be optimized for other specific cases. And of course, there is a novel product on the market from Mantispectra that that has a similar ideology, I would say, but different realization. They use 16 detectors with various filters and one broad light source. Yes, but these detectors are much cheaper and gives you at least the same quality or better results compared to spectrometers. Yes, and here are just an example of transaction fiber probes. For food industry, I would say it's also important to note that for food industry, in some cases, there's special hygienic 3A standard must be used, and you see the probe on the right, Transflex probe, that can be used for transmission or scatter-based measurements. That's very smooth and so on. So we can do that, and just conventional Transflex probes that gives you data about ethanol and water and other alcohol concentrations in the samples. And of course, the reflection probes for grains, sugar, coffee,
Alexander.
and other. Yeah,
sorry,
I'm at the end. Yes, very, very sorry. So here just want to show. Yeah, thanks all for your attention. Sorry for being a little bit out of time. If you have any questions, feel free to ask. Thank you.
No problem. Yeah, no problem. Thank you. Thank you very much, Alexander, for your presentation. Any question for Art Photonics? You can raise your hand. Okay.
Yeah,
thank you again.
I would add that a lot of customized things for these multi-sensor systems, a lot of customized things must be done. So we do these customized probes. So we are open to solve your challenge.
Sure, thank you, Alexander. If you need to be put in contact with Art Photonics, you can contact Alexander directly or contact me, and I would be pleased to introduce you to Art Photonics. Thank you again, Alexander. Thank you very much. So now let's welcome our next speaker, Maria Cardona from Embutidos Martinez. So Maria, yeah, you can start the presentation. Thank you. You are muted, Maria.
Good afternoon to everybody. My name is Maria Cardona, and I try to share my presentation with you. I think it is, yes, here it is. Well, I am responsible for the food safety and quality control management in Familia Martinez. And first of all, I would like to thank the EPIC organization for having me for the third consecutive year participating in this nice event. And I really hope that you may find of your interest our presentation. And now I would like to introduce a little bit who we are and what we do in Familia Martinez. Familia Martinez has diversified its activity in three main branches. We have the food division arm. We have also a technological branch. And then even Familia Martinez has created its own innovation hub. So at this point, I would like to share with you, which is our vision. In Familia Martinez, we want to improve people's daily lives through food. For that, we create solutions for people to eat tasty, healthy, easy, and sustainably. So we think that with this solution, we can achieve our mission. At this point, I would like to briefly introduce the companies that form our food division branch. Familia Martinez employs 1,700 people, and we have 90,000 square meters for productive activity. Our food division is formed by 5 companies. The first one I would like to present to you is Embutidos Martinez, which is the one that I am representing today. And we manufacture processed meat. We produce burger meat, sausages, and burgers. And I would like to point out that we were the first company that implemented PCR technology for the detection of pathogens in meat and meat products in the year 2008. Then I would like to tell you a little bit about our second food company. It is called Platos Tradicionales, and is a B Corp certified company. We are a specialist in cooking ready-to-eat meals, and Embutidos Martinez and Platos Tradicionales are located in Valencia, in Spain. The third company is Cinco Tenedores, in which we produce fresh meatballs and artisanal roasts. Also, it is located in Valencia, in Spain. The fourth company is located in Madrid, in Spain also, and we produce there wraps and toppings for the food service. And the last one is Quiku Company, in which we produce customized burgers, fresh or frozen for the food service, and ready-to-eat meats and roast. Once I have presented briefly the companies that compose our food division, I would like to tell you a little bit in terms of our technological activity. Familia Martinez participates in a company called DCM, which offers complete custom engineering solution, and they have headquarters in Spain and in the States. They offer mechanical engineering solutions, as I said, for the food industry, and they are experts on automation, robotics, and vision systems. We have in our production lines, we have several of these solutions implemented. And as I told you before, Familia Martinez has its own innovation hub, which is called Kilómetro Cero, and connects startups with companies, and have created a growing community, and they create specialized reports annually, and they hold events in Spain and in Mexico. So now I would like to tell you which are our main needs that are mostly common for the food industry. We need food inspection machinery for detecting real fleeting foreign objects in raw materials and packaged food. Also, we need cutting-edge technology to ensure consumers' most appreciated quality cues and sensory profile, related these to physical attributes and chemical properties. And we are very focused and oriented on customized hygienic solutions and technological devices for hard-to-reach areas treatment in food production plants. We need to reduce the consumption of water, chemicals, and we need to increase the available time for producing. These lines, we think that are the main aspects for the company's sustainability. But in addition, we would like to point out some other requirements for the technology. We may need tailor-made measures considering the technological requirements and our industrial designs. And technology must be major enough to be tested in a real production line. What it is clear for me is that the real challenge is to bridge technology and the production plant. As an end user, our decision must be easier and always based on reliable feasibility studies and value return analysis from industrial testing. This is very important because to plan an industrial test requires investment, and only with this we can decide whether go or not to go, and this is a main point for us. I would like to end my presentation with a sentence that I think is very appropriate for this presentation. That it is our founder always says to us, everything that is worthy is not easy and it's not close. And I think that this challenge is something that we have to focus on that. So thank you very much for your attention. And I hope you might find our challenges as interesting for your purposes. Thank you very much.
Thank you very much, Maya. Always interesting to get your inputs as an end user. So, do you have any question for Maya? I'm pretty sure that companies here have some question. Maybe I will start, Maya, with one from my side. So we understand that you are quite far away from, I would say, photonics, technologies in the value chain. So how do you see photonics technology, and how do you think that they could bring some solution to you? So I understand that there is also a problem on how to work with them. So what is your idea on this?
Well, we have implemented several solutions. We have X-ray devices in our lines. We have near-infrared spectrometers in our labs. And we have several machinery for antibodies detection. But we need solutions. For example, what is the main point for me is, of course, we have to need good results in a pilot test in food matrices, which are very complex matrices, as all you know. After this initial testing, once we decide to scale up, we need engineering solutions, even though for the testing stage. And this required investment because any modification in our lines it has an important cost because we have to re-engineer the line and create, removal systems, and I mean, it is very an important investment. And then only with this we can obtain, these feasibility studies that are going to make true to take that decision. I mean, is it worth to invest with this? It will be successful. So this is a question that makes us stuck in this position. So I think we have to bridge in some way the pilot testing, the industrial testing, to make easier for the end user to justify the investment in a technological solution. And I think that it is very important, the integration part, but not only in the production as a production stage, but also in the testing, in the industrial testing.
Yeah, it's an interesting challenge that we could work together on it, Mario. Yes, again, you have a question, please.
Yeah, hi, Maria. Thanks for an interesting presentation there. Have you got a specific example of a challenge that, if it was solved, would make your life much easier?
There are plenty of them. We are very conserved in terms of food safety. So all technological solutions that may detect foreign bodies are very important for us in raw material and final product, especially with packaged product. We would like to check 10% of our product. So inline control is very important, but it has to cope with the production.
The speed.
Yeah, the speed. Yeah. That's and non-destructive is one level of sustainability very important to take into account.
Yeah, and
also everything that has to do with the food safety, like quick detection in terms of microbiology, pathogens, and food quality control in terms of fat, moisture, ashes, protein, fat content. It would be great. We have implemented devices for the control. We analyzed 7% of our raw material with X-ray equipment for detection of foreign bodies, but also we measure the fat content and protein content of every box of raw meat. So we have a good control, and we are talking that we need anything that is better than what we have implemented.
Yeah.
So in speed, in accuracy, maybe I am very interested with what you said before, employing AI and deep learning to make a predictive control, a predictive quality control. It will be one of our best wishes.
Okay, thank you. Yeah, maybe we could talk offline in the coming days. Yeah, thank you.
Thank you.
Thank you, and a second question from Carol De Vries from Photon Delta. Carol, short one.
Yes, thank you. I'm Carol De Vries from Photon Delta. We support many integrated photonic new initiatives and startups. And my question has to do with the process that you see in order to cooperate with these small companies, because we understand you need to validate the reliability and the quality of what is being done, but small startups often cannot sustain very long processes without any support. So how do you do that? Do you give them advice? Do you have a certain approach with these companies? What do you do?
We receive the whole service. I mean, the solution, the end solution, and from time to time we need to, through our engineering solution enterprise, we do all the machinery or the engineering design in the line to integrate the devices. I'm not sure if I have solved your question.
Yeah, but I know you have certain requirements, but are you helping startups, for instance, with advice how to do this, or do you just wait until something is completely ready and finished?
Yes, I think, as I said in the presentation, we need the technology major enough to be tested in an industrial environment, and then we need engineering solution or machinery or design to include in our line. So we need an integration with both of them. A major technology with a engineering solution to test in our line.
Okay.
Thank you, Carol. And the last question, please, Francesco from Mantispectra.
If you can hear me.
Yes.
Thank you very much, Maria, for your presentation. I have just a very quick question related to the one from Carol. So in your experience in the past, more or less, what is the time scale for implementing this integration in line and in the industrial environment? So how long does it take for you so far to test this technology, check that they are ready for what you need, and then goes to the, let's say, production phase?
We usually are supplied with the end solution, but we are developing. We have been participating in a project that has taken us 3 years.
And these 3 years are, let's say, the order of magnitude you are confident with, or you try to have a much faster implementation?
No, we are not comfortable with this time. and the results, even though the results have been, positive, but it's a long time for us because as an end user, our activity is to produce final products, so we need more help in the sense that we need a tool that is more major.
Clear. Thanks.
You're welcome.
Thank you, Francesco. Thank you again, Maria, for all this input. So thanks a lot. Yeah, Francesco. So you can stay with us. It's your turn. So the floor is yours, Francesco Pagliano from Mantispectra.
Yeah. Good afternoon to everybody. I'm trying to share our presentation. Let's see. I hope you can see.
Yes, it's not in full screen mode, but okay, good. Thank you.
Fine. Okay, so good afternoon to everybody. I'm Francesco Pagliano. I'm a co-founder and actual CTO of Mantispectra. And today I will try to reply to two of the main questions from the EPIC meeting. So what can Mantispectra do for their customers or partners? So Mantispectra is a spin-off from the University of Technology of Eindhoven. And after many years of research and development, we were able to shrink down the functionalities of a very big and large spectrometer into a semiconductor-based spectral sensor. And the reason why we try to develop this technology is because we think that the 4.0 industry of the future really needs to see what is inside the materials. So you really need to add information from the world around you that are of a chemical type of information. So the amount of certain chemical compounds in the material in the world around you. And we decided to do following, let's say, the semiconductor approach, because with semiconductor technology, you can greatly scale up the technology and therefore improving certain specs of the sensor and at the same time reducing the cost. So today I will present you the results of all this year of development and optimization that gives rise to what we call the chip sense, that is core technology that we propose as a company Mantispectra. So the chip sense is a sensor that you see here on the fingertip of a finger that is able to provide a miniaturized, high accurate, low cost, and very fast spectral sensing detection. So the first goal of our commercial offer was towards industries that nowadays takes really a lot of time to perform quality control on the raw material, on the processing during the industrial processing, to the end product, the packaging, the logistics. So most of the time, all this industry takes, as Maria was also describing very well, a lot of time to do external experiment in order to check the quality of the raw material that are processed within the industry. And this takes not only a lot of time, but also a lot of money and a lot of waste. So our goal is basically to provide, thanks to our chipsense technology, an on-site, cost-effective, and real-time measurement. So how does this technology work? So basically, it's a spectral sensor. It has, as Alexander from Photonics was properly describing at the end of this presentation, 16 detectors that are coupled with a relative 16 filtering integrated filters. And the nice things of our technology is that we do this monolithically. So we develop a semiconductor process that can really fabricate the detector and the filters at the same time during the semiconductor micro and nano fabrication. And this means that you do not have moving parts, you do not have the packaging cost involved afterwards. You can choose the different filtering central wavelength and full width of maximum of each of the filter according to the specific application that you like. And of course, we create the initial chip sense to be as more universal as possible but depending on the volume and the application, we can tune the filters at the fabrication level in order to have more filtering or more prediction capability for certain application. And the nice point is that we have integrated all these already high technology and quite unique state-of-the-art semiconductor technology with machine learning, with artificial intelligence. So our solution is already integrated at the same time, the hardware part and the machine learning part. So basically each chemical compound can have its own spectral fingerprint. So each detector, each of the 16 detectors can detect a certain part of this fingerprint. And then we can create a calibration model that is basically training the brain of our sensor, telling them what they are seeing. After a very robust or very complex model is created, from their own, the sensor can just be using prediction, using the specific model that has been created, and can provide classification or quantification in real time in fraction of a second. I say classification and quantification because actually with our sensor and the machine learning, we can address both of the two different applications. So you can quantify objects, like quantify the material, the amount of protein in milk, the amount of fat in meat, the amount of caffeine in coffee, and so on. But you can also classify. And for example, you can train our sensor, our solution, depending on different class of material. For example, you can train the model on different type of coffee or on different type of plastic or different type of tissue. And therefore, you are at the end a classification model where our solution can immediately, in real time, differentiate between different type of plastic or of drugs, of coffee, or and so on. So the reason why we are working in the near infrared and SWIR, so between 900 nanometer to 2 micrometer, was really well already expressed by Ian from Vortex, is because in the SWIR regime, there are most of the second order overtone, some of the most crucial chemical transition that we see in the material that we analyze. So something that is really impossible to do with the visible, with the silicon CMOS-based technology, is possible to do with the SWIR technology. And of course, our technology is based on 3.5 materials, but we are also working in the direction of extending the range above 2.5 micrometer, for including ever-growing range of chemical compounds that we can measure with accuracy. So here you see just one of the initial run we were developing, where we can fit theoretically thousands of devices on a single wafers. And this, as you may understand, is the only technology that can really bring spectral sensing towards a more consumer-based application, like consumer appliances, household appliances, and optimally in the future also to smartphone. Because since we can create our sensor monolithically, we can process thousands of devices on a single wafer, therefore increasing yield and decreasing cost. So the chip sense technology, the one that is semiconductor and scalable, is the core of our solution and our offer. But in order to allow our customer basically to be able to integrate this very advanced technology within their application field and their integration, we develop also a full set of different devices that are, let's say, living around our core technology. And in order from left to right, an OEM board that is already performing the readout of the sensor in a very smart and unique way. In the center, the spectra pod that is including not only the chip sense semiconductor sensor, not only the electronics board, but also the whole optical, let's say, infrastructure, let's say the optical assembly that enables to measure already sample and material directly using what we call the spectra pod, the development kit. And we have also developed a cloud solution that allow all our customers to very easily start to use our spectrum. And this it sounds to be just an add-on of our technology, but actually it's really, really important. Because as the market will see more and more in the future, spectral sensing and the revolution of spectral sensing industry will be also very, very linked to the way the models are created, the way the material are scanned. And having a online platform that allow to easily create model, calibration, build up the library of the kind of application you want to measure could be a crucial difference between using this technology in a fast way, direct way, and not using it. So the Spectra Web, what we call that we enable beginning of 2023, is also one part of the solution that we offer in order to integrate our hardware technology and our software, machine learning, artificial intelligence capability. And from what concerns the hardware, we have also developed on the hardware side, especially for the development kit, a full set of different shields, of different add-on that is allowing so far our customer worldwide to test our solution in different configuration, in different environments. So you can measure in contact mode, in reflectance or transreflectance. You can measure even in transmission when you have liquid or semi-transparent powder. I mean semi-transparent in a wire, of course. Or you can even couple to fibers, like the fibers from our Photonics, for example, if you need to measure at long distance on in harsh environment. So these are different optical configurations that allow our customer to test our solution and already start to think about the integration and implementation in the future. So here you see just a couple of applications that show you more or less how the solution that we propose work. So in this application, we try to measure the moisture content in grains, rice, for example. And the way the moisture content is measured today is pretty difficult and also time consuming, because the grain, the rice, has to be weighted, measured and weighted before, in order to understand what is the amount of water that is contained in the rice. And this takes a lot of time to measure, because you need to do a lot of measurement, heat up the rice, and then wait afterwards. And we actually did this once in order to calibrate our sensor. And in one afternoon, we were able to create a model that is describing basically the amount of water in rice. But once the model is created, then the sensor can be used directly in real time on any kind of other rice in order to provide directly the amount of water that is contained in the grain. And you see on the right, for example, this regression correlation between the expected percentage of water and the measured one, with around 95% accuracy. Similar concept was adapted for the measurement of fat content in milk. In this application, we use a fiber submerged in a calibrated sample of milk. So by using calibrated sample of milk, we could create the calibration model for our spectropod. And we were able afterwards to retrieve on an unknown sample of milk the amount of fat, with an accuracy of about 98%. So this kind of approach seems to be very valuable for a lot of industry that start to be the pioneers of the spectral revolution, adopting our technology. So with them, we already embarked in a proof of concept phase 1 year ago, and on integration phases that allowed them to start to integrate our sensor really in their pilot line, in the industrial environment. And with some of them, we're already discussing about volume, because the improvement that they could see in terms of cost, of course, because our sensor cost order of magnitudes less than a hyperspectral camera or a huge spectrometer, but also in terms of quality control, because for some customers, sometimes not having a quality control on the raw material could be really a disaster in terms of product recall or re-optimization of the industrial process. But the nice thing is that you know this technology is just a platform, so it will enable a full plethora of application. This is why we have been contacted in the last 8 months also from many home appliances and customer appliances company that are willing to bring this technology towards the consumers. But the problem that so far the price was one of the bottleneck for this implementation. So by providing a solution that is very accurate, thanks to the very high signal to noise ratio that we can provide, and a low cost, we hope that we can really enable the adoption of this new technology everywhere. So I hope I describe you enough what are our main core, the main core of our offer. But of course, we are a team of very enthusiastic people. So if you would like to contact us, just drop us an email and we can discuss with you your idea, your application, how we can better help you in solving your problems. Thank you very much.
Thank you very much, Francesco. Thank you very much. Any question? Maybe one question for Francesco before the last speaker. We have a question from YouTube. Francesco, do you consider to include the GSB, gas SB sensor in your detectors related to cost consideration?
If I understood correctly, they're asking if we are willing to integrate gas cell.
GASB, gas.
Yeah. The kind of configuration that we create so far are some of the initial configuration. The easiest one, let's say, is a reflection, transmission, and fibers. But of course, we are already looking into developing also more complex architecture where we can have also multiple beams and even cells, flow cells or gas cells to measure. Of course, we are using 16 detector with, some people already call them narrow, but we call them a broad filtering. So it's a matter also not only of the infrastructure around the detector, but for gas sensing or for this kind of specific applications, really to choose the range of filters that are more optimal for the kind of application that people want to target.
Thank you, Francesco. Okay, thank you again, Francesco. Thank you very much for your presentation. And now I would like to give the floor to Robert Tankeren from InPhocal. So Robert, you can start. Thank you.
Yes, good afternoon. Thank you for this opportunity to pitch InPhocal to you. My name is Robert, co-founder and CEO of InPhocal. And I want to talk about our unique optical technology that we are currently using to increase the efficiency of several different laser applications. And the best way to go into a bit more about what it is that our technology makes us unique, I always go into the first use case that we're currently going for, which is this. Every day over 5 billion cans and bottles are sold, and all of them have an expiration date printed on them. Typically, this is done with ink. Now, as a result of that ink is actually polluting the environment. We did a rough calculation that over 160 million liters of ink end up in the environment each year as pollution. But it's also maintenance-heavy technology, meaning it causes a lot of downtime because of the maintenance that the inkjet printers need every single day. The good news is there is an alternative that was actually already accepted by the entire market with all the major players, and that is laser marking. The bad news of this is current laser technology, if you compare it to the inkjet and the specifications that inkjet can offer, then laser technology simply doesn't have the speed or the amount of print that inkjet can provide. This is actually where our unique sweet spot is. Basically, what we've done is we invented and patented a unique optical technology that actually allows us to not only match, but actually even outperform the technology compared to inkjet systems. And what our technology does is, in this case, actually increase the focus depth of a normal laser beam by several hundred times. To give you an idea, and this is probably something that most of you are already well known in, if you look at the intensity distribution of a normal laser beam, you see this on the left-hand side, this Gaussian beam distribution, where the intensity is spread out evenly. Our passive optical systems, meaning there's no active measurements, no active components involved in it, actually change the properties into what we call the concentric laser beam, which has a very narrow spot size in the center, where the majority of all the intensity is located. Now, next to this intensity distribution, there's one major aspect that our technology also does, and the best way that I always describe it is if you compare it to a magnifying glass. If you use a normal magnifying glass to burn a hole in a piece of paper, as you can see here, you need to position the paper exactly in the focus point of the magnifying glass. And if you move it a bit closer to or further away, you can still see the light hitting the paper, but it's actually not burning that hole anymore. Now, typically lasers work in the same way. If you want to make a laser do anything with the object it's hitting, you need to focus it onto that object, and you use optical elements to do that. And the error in positioning is actually very small, usually a millimeter, meaning that if you are off by even a millimeter, that laser will not be able to put all the intensity of the laser beam onto the object. Now, our technology basically creates a way to increase that margin of error by almost 100 times, meaning that instead of having 1 millimeter in focus depth that you can play with, our technology will actually be able to give you almost 10 centimeters of focus depth without losing intensity. So if you then put that same technology into a production line, that means that you can actually increase the speed of the production line. You can also increase the amount of print. And what you can also see here is we also have full flexibility with regards to the distance to the printer, or actually also the curved nature of objects that you want to hit. We can mark just as fast on any kind of curved surface as well, which is something no other technology can do without having to add expensive and active focus systems. So what we can do is we can increase the efficiency of a production line and at the same time make them more sustainable and more cost effective, with the capability to mark on different kinds of surfaces, both in shape, but also in types of material. You can also see a few of the examples here, which are even including organic material. So the most commonly used lasers for this type of marking are fiber, CO2, and UV. And our technology works with all of them, allowing to not just focus on expiration dates, but also other kinds of marking. And we are covering the full spectrum of materials. So if you compare to the current technology on the market, we can outperform them on all the relevant parameters, and we can optimize the systems for the specific applications. Now, from a market perspective, we're currently setting up pilots worldwide with some of the biggest names in the industry, where we are specifically focusing on the food and beverage industry for expiration dates, but also for data codes, which is something that we can be using for both traceability and authenticity. One of the companies that you see here is the company LVMH, which is Louis Vuitton Moet Hennessy. We are currently part of one of their programs. And to give you a snapshot about the potential of our technology, I just took one of the brands that is located within the LVMH program, and we can mark any kind of product or any kind of surface area on this product with either a QR code, a personal message, something to trace the bottles with. And we can do that both in factory, but also in store. And if you look at industrial setup, this is a current pilot project that we've done for one of the beer brewing companies that we are now partnering with. And to give you an idea, this setup, we can actually print an expiration date and a QR code or a data code in under 20 milliseconds. So that's over 2,000 cans per minute. And all QR codes will be unique. For in-store applications, we've built a custom setup that we can place in a system, in a store, with a simple user interface where you can just write a personal message. And while we are starting with the marketing industry, and specifically the food and beverage industry in this market, our technology is not limited to just that. We've already done a few pilots on laser cutting, and we're currently setting up the first experimental results for wafer singulation. So using our technology to make a more efficient way to cut out wafers into individual chips. And I always want to mention the team that we have. It's not just me doing this, of course. We were able to build in the past 4 years, InPhocal was founded in 2019, a very diverse and international team of highly skilled experts together with young, new, talented people, and with a ratio, including the tech team, of about 50-50 between men and women. So far, we've been supported by the European Innovation Council, our own investors, the CERN Institute, where this technology was originally scouted. We now have 5 patents of our own on this technology, but we still have a collaboration with the CERN Institute, and we have won several awards. So we are confident that with our technology, we can actually succeed in our mission to rid the world of unnecessary waste. And to just give you an idea about how our technology would actually look like in practice, let me just turn off the sound. Here you can see a few of the examples that we've done in the lab, from marking on curved surfaces to adding an individual pattern on, in this case, computer hardware, without having to measure or compensate for the shapes, or ablating the top layer without damaging the permeability of the foil, and even just the increase in speed compared to traditional laser-based marking technology. In short, this is who we are. This is InPhocal, and this is Light Without Limits. So with that, I want to thank you for your attention.
Thank you, Robert. Thank you very much for your presentation and being on time. So, yeah, any question for Robert? Maybe I have one from my side. So I guess that in function of the material you want to engrave, you use different kind of wavelength, different kind of laser. So do you have any specific needs on this, or?
Currently, we are still optimizing our system. One of the things that we've come across is that due to the fact that our hardware is capable of marking faster than before, we actually run into software optimization issues. So anybody with experience in software optimization and control cards optimization would be highly appreciated. And what we've seen so far is whenever we talk to people about what our technology can do, they typically come up with new applications. So we're always open for any kind of new ideas that people might have, and where our technology could be a huge and important factor.
Yes, Francesco, please.
Yes, thank you very much, Robert, for your nice presentation. I have just one curiosity. The core part of your technology seems to be the Fabry-Perot lens, or these meta-surface lens. Do you produce it in-house, or you're using external provider for these lens?
We have an external producer, or a manufacturer of our optical components, but it is something that indeed we have developed in-house, and that is indeed exactly the added value that we have. So we developed this. We will outsource the production of it to a partner that is experienced in producing these kinds of optical elements.
Okay. Thanks.
Thank you, Francesco, for your question. Okay, so thank you again, Robert. And yeah, we are a little bit late. So thank you very much to all of our speakers today. I think it was really interesting. If you need to be introduced to one of our speakers, one of companies which attended this event, you can come to me afterwards, and I will be pleased to do this introduction. So thank you very much again to all of you, and see you next time for another event. Would I just remember that we have this event on agri-food technologies in next April in Oslo. So just have a look on this on the website, and if you're interested, you can come again to us. Thank you very much, and enjoy the end of the year and all the Christmas fest. Thank you very much.
Thank you. Bye.
Thank you very much. Bye-bye.
Thanks. Have a good evening.
Thank you. Bye-bye.